Good morning, everyone. Good afternoon, good evening, everyone, wherever you may be in this part of the world, and welcome to another session of my presentation. And my presentation title is Developing and Implementing a Strategy and a Roadmap for the Replacement of Vintage Style Oil Circuit Breakers. My name is John Kweku Amotu, and I'm a professional electrical engineer for about 30 years, and I'm based in the United States. Next, we'll go through the outline of my presentation. First of all, we'll talk about the importance of these oil circuit breakers. I mean, they've been in operation about 70 years ago, 60 years, 50 years, and basically, have operated reliably, and matter of fact, has provided the required security in the power system network that they are integrated or connected. And I will also talk about the current challenges that we are facing with this vintage style oil circuit breakers. Then we'll talk about how to develop a business case justification to basically support the replacement of these oil circuit breakers. All the parameters, all the elements that you need to consider. Then we'll talk about how to obtain the population list of all vintage style oil circuit breakers. There are a lot of parameters that you need to obtain, and basically that is what you use to basically build up your Excel sheets, and you will evolve it to also creating pie charts, and histograms as well. Then I'll show you how to obtain the list of spare circuit breakers that you will use. As you know, since these circuit breakers are very long lead items, so you want to basically start off with what you have in your inventory as spare circuit breakers. Then I'll show you how to identify a timeline for your replacement strategy. Then where to obtain your asset risk score, asset risk cost, and also your asset risk matrix. Then I'll show you all the list of criteria that you need to consider when you are implementing this replacement strategy. Then your material requisition, and basically utilizing your blanket purchase order to basically, place an order for these circuit breakers, based on the portfolio mix of circuit breakers that you have, the vacuum type and the SF6 type. And also you can consider non-SF6 breakers, because technology has evolved that, now some of the states, a state like California is basically pushing non-use of, SF6 breakers. And basically they are moving to alternative gas. Then we'll talk about the resources that you need to implement successfully this strategy. And the resources are from engineering, maintenance, and operation. Next is estimating the cost. Coming up with a nice roadmap and strategy like that, you need to basically calculate the cost and the cost of replacement of the breaker itself, and also the cost of installation of the breaker, pre-commissioning and startup, and basically considering the cost of breaker, pre-commissioning and startup, then basically that's when labor cost comes into play, and a material list, basically, the cost from other additional materials that you will need. Then also, identifying the list and quantity, of different circuit breakers that you're going to source. And the different circuit breakers are vacuum, SF6, and non-SF6 breakers. Okay, so now let's move on to the importance of vintage style oil circuit breakers. Right. Okay, so like I indicated, these breakers were manufactured about 70, 60, 50, 40 years ago, and have basically operated reliably and successfully for most part of their life cycle. It's just quite recently, about a decade ago, that a lot of problems about this vintage style oil circuit breakers started creeping up. So they are very important in the power system network that they are integrated, and provides the required security and reliability into the integrated power system network that they're tied to. Now let's talk about the challenges that we're currently facing about this oil circuit breakers. Remember, I made mention that a lot of the problems and issues with this vintage oil circuit breakers started from about 10 to 15 years ago. Because if you have one that has been in operation for 70 years, then definitely after 40 years, that's when you start seeing a lot of the problems. So the first item that we need to consider is the aging. Like I made mention that a lot of them have aged. Basically, as an equipment has been in operation for that about 40 years, 50 years, 60 years, 70 years, for that matter, it deteriorates whilst it's in operation, right? Okay, so the aging itself, becomes a factor. Then next is the cost of replacement of the components. The circuit breaker, as it was built, many decades ago, a lot of these parts, spare parts, and all those things, are very costly. I can give you a typical scenario where basically, I think one of the breakers, has basically, failed to close, and basically, we had to basically investigate, and basically it was we found out, it was a latching problem. So we went ahead and basically, fixed, requested, for parts for that. Then after that, that itself did not guarantee its reliability, back to service, operation. And basically after that, it did not operate as we wanted. So we basically, took it out again, and we found out that there were other problems that basically, we did not see. So there is that possibility that if a problem comes up, and even if you are able to get a part for it, the cost of the parts are so expensive, and when you replace that part, then you end up finding that there are other problems associated with that breaker. So much to say that there are other hidden problems that you end up finding if and much additional costs comes into play. Next is the material requisition. Like I indicated, apart from the fact that the components and the parts are very costly, creating the material requisition and getting a vendor to even provide it for you or source it out to you is sometimes can be very challenging. Finding, especially for oil circuit breakers manufacturers that have basically gone out of business. Then basically you have to basically get basically a fabricator that can basically fabricate that component, and basically through reverse engineering, and that itself can be very costly. So material requisition can be very challenging with this vintage style oil circuit breakers. Then vendor support, like I indicated, that some of the OEM and manufacturers are basically tanked, have gone out of business, and basically design drawings and everything, everything it's gone out of it, and it's not there, and also there are other ones that are even in business, and basically they don't provide, they'll tell you they don't support. So vendor support sometimes can be very choppy, and you'll be lucky if you find a vendor to basically provide the support that you need. Sometimes in performing investigation, or basically when these oil circuit breakers basically fail to operate, sometimes you have to tap into these OEMs, and if the OEM is not around and does not support the breaker, and that's the challenging part. Next is the retiring of industry technical know-how. Like I made mention that these breakers have been in operation about 40, 50, 60, 70 years. And basically, the older people that basically know the breaker, and they've all retired. And now we have generation X, Y, Z, uh, industry, technical people, and the know-how. I'll say, transferring the know-how from these retirees to this younger generation, wasn't done right, So there are these younger generation that basically don't know these oil circuit breakers. If problems comes up that they have to investigate and basically implement corrective actions. Next is the reliability of repairs, right? Okay, like I made mention that sometimes um, a oil circuit breaker will basically trip and or fail to close. So, and basically you implement the required repairs per the instruction manual, right? Then after that, if you return it back to service, then it's not going to operate reliably again. Another problem is going to come up. So the reliability, sometimes can be challenging. As these components age. Yeah, that is fixing one problem basically results in you finding other hidden problems or inherent problems that were there that did not show. Next is the hazard after a catastrophic failure. Like I indicated, basically, these oil circuit breakers are like vessels, and basically containing huge gallons of oil, right? Okay, so um, the slightest problem would even DGA, gas, huge gas in it, can basically cause an explosion, right? And so, I mean, it's basically exploding, can basically cause uh, basically damage to adjacent equipment. Let's say, you have an oil circuit breaker that is in close proximity to other substation equipment like power transformers. Definitely, it's when it explodes, it's going to cause a huge, damage. And much to say, if you have personnel that are working, in that area, then that itself becomes a hazard in terms of endangering, these personnel that are working in close proximity. And a matter of fact, some of the catastrophic failure can cause big fire that basically can take a whole substation now. So that itself becomes a major challenge and a concern. Next is loss of feeders to critical customers. As as much as these oil circuit breakers have been in operation, a lot of these substations are also vintage. They've been in, they were built, 60, 70 years, 50 years, way back, right? And some of these provide critical power to critical customers, right? So basically, if you should have an oil circuit breaker, failing catastrophically, right, then basically, you're going to lose that feeder to uh, feeder providing power to these critical customers. So, the critical customers basically, have to be sourced from another feeder if you have redundancy in your power supply. So that itself, sourcing it from another circuit basically overloads the other circuit. Then, I made mention that some of the OEMs are not in business, better support, and that ties into better support and getting the drawings, sometimes, you see that, even getting the manuals for these oil circuit breakers can be challenging. The operation maintenance manual can be challenging. Yeah, so, the previous slide, we did talk about the challenges that currently, we are faced with oil circuit breakers. So that itself, gives us the justification to basically, plan for the replacement of these oil circuit breakers with equivalent circuit breakers that are much more reliable. Okay, so the next thing you want to do is develop a business case justification, and that itself involves, first of all, you need to set up a collaboration meeting with our stakeholders. And what are your stakeholders that basically should be tied to this replacement strategy? Those are your operations staff, operation foreman, if you have one, maintenance staff, maintenance foreman, engineering manager, and basically, design engineering. Yeah. So, and asset management. Asset management group should also be part of this collaboration. So, know the departments, know the units that you need to uh, tie in as part of your replacement strategy, and basically build up the collaboration with them, and through periodic meetings, and basically giving them the progress, and also having them provide an input to basically support your implementation strategy. Next is reviewing all your failure history, right? Okay, so if you have an asset management software, right, or program, right, basically, and that's why basically you have all your maintenance history. So you should also have a failure history, and basically you should be able to get all that information and present it to your stakeholders. So that itself should be part of the meeting, and present it, the challenges that you are facing, the one that I presented in the previous slide, and also the failure history that you are facing with this circuit breakers, and also operational history, the challenges in operating it reliably. Then obsolescence, obsolescence is very important. By presenting it to them, like I indicated, getting vendor support for these sometimes can be challenging. So they've basically, a lot of them become obsolete. Vendors are not supporting it anymore. And even then, if they are supporting it, sometimes getting that support can be challenging. And also, the cost to repair it. Uh, I made mention of that in the previous slide, and also the cost of the parts. Sometimes the costs of the parts are so expensive, even than a new circuit breaker. So why do you want to basically spend that amount of money to replace a part, to basically return a circuit breaker back to service? Why don't you plan for its replacement? Next is basically the challenges that obtaining the required parts, and I think I've made mention of it, and also present it to your stakeholders, and let them know that it's very challenging getting the parts. Then also present your maintenance history and engineering records of oil circuit breakers. Then also present a brief of the benefits, what basically the power system network in the business will benefit after these replacements are implemented. In terms of we're going to talk about basically getting the whole big picture, cost reduction, maintenance reduction, and also the circuit breakers will operate reliably, and you're going to have a secure power system network. Next is obtaining the population list of oil circuit breakers that you have, and build an Excel sheet with that data. That is very important, and yeah, because everything has to be visualized, and now with data analytics, you can even put it in more of a data visualization and more of a chart, because if you're speaking to upper management, basically data visualization is very important, and Excel sheet helps you to build up that step. Okay, so in getting the population list and building it into an Excel sheet, these are the parameters that you need. The name of the substation that the oil circuit breaker is located. That is very important. So that should be in a column by itself. Then the asset number. As asset management has become prominent. Every utility is basically implementing asset management. So basically Most of the utilities have assigned asset numbers to every equipment. So basically, you need to include that asset number of that oil circuit breaker. Then the manufacturer, so definitely, you have oil circuit breakers. You're gonna have, you can have different manufacturers for these oil circuit breakers. Then there should be a unique manufacturing identification tag. Usually, but the manufacturers give us, the serial number for this circuit breaker. Next is the location. These oil circuit breakers are located at a specific, different, depending on the orientation of, the substation. This is basically done based on GIS, Geographic Information System, and they are given unique location tag based on the position and the orientation of the substation to the incoming and outgoing feeders. Next, you should have a column for voltage rating of the circuit breaker. Then another column for current rating of the circuit breaker. Then another column for short circuit rating. In getting the short circuit rating, you can have a symmetrical short circuit rating and asymmetrical short circuit rating. Asymmetrical is basically the peak short circuit rating. And you can get the break and the make asymmetrical short circuit rating. Then you can basically have another column for the mechanism type and model. As different breakers based on different voltage levels, different manufacturers will have a different mechanism type. And basically, another important parameter that you need is the most recent available short circuit rating at that location where the circuit breaker is located. Because sometimes there have been modifications to the power system network where the circuit breaker is located. And as modification, additional lines are added, basically it changes the available short circuit rating. Or let's say there's a planned addition of transmission network. So that itself will change the available short circuit rating. So you need to account for it and capture that as part of your replacement, because definitely you want to replace it with the right circuit breaker that has the right short circuit rate. Next is the risk score. The risk score is very important, and your asset management department will basically provide you your risk score after they have done the asset health index. Next is the risk cost. The cost of the risk is also calculated, and your asset management department will provide you. And also time left for replacement. That is intervention time. So they will also provide you that information. Then the cost of a replacement breaker, right? Okay, so you can get the cost from, if you have a purchase blanket order, and let's say with different vendors, General Electric, Siemens, ABB, they will give you, the cost of these breakers. Periodically these costs are updated. Let's say it's updated, based on the cost of inflation, or how the economy is going. I think that they are updated about once or twice a year. Then the cost of the full replacement of the replacement breaker. The full replacement basically includes the cost of the breaker and material and labor cost. Right, that is labor cost that is used for the installation, pre-commissioning, commissioning, and stuff. Next is the data visualization part, right? I indicated, as with, we are presenting this data to upper management. So data visualization is very good, So you want to build pie charts, and, utilizing manufacturers, based on the different number of circuit breakers and the quantity, and substation location, mechanism type, voltage level, and current level. So you can build different pie charts and basically as part of your strategy and implementation. Next is basically getting a list of spare breakers on hand. Definitely, you should have spare breakers for each circuit breaker that you have, right? Okay. So let's say, for 115 kV oil circuit breakers, definitely you're going to have a spare 115 kV SF6 spare breakers that you have on hand if that oil circuit breaker should fail, to operate, and after performing the right investigation, then basically you put in repair it. Then definitely you have to perform a full replacement. Aside that, you need spare breakers. So basically, what you want to do is get a list of the spare breakers you have, and you need to verify the rating, because first of all, you are getting the information from your asset management software, right? Okay, so that itself, basically, that information was entered by human, and they can make mistakes. So very, very important to verify the rating, which the asset management software gave you with what is in the field, so that itself requires a field visit to verify, the correct rating, So if you have, because I mean, based on experience, I've run into several scenario where basically the rating information that was given in basically repository was totally wrong with what is in the field. Then also, you want to verify any maintenance history of the breaker, right? Okay, so some of these breakers, whilst they are in storage, are basically maintained. So you want to check the maintenance history, make sure that the breaker inspection and testing results is good. Then you also want to verify it has a vendor engineering drawings and vendor instruction and operation manual. Then, like I indicated, after getting all this information, the list, and verifying everything in the field, you also want to check its readiness, right? So, sometimes there's something they call salvage, and most maintenance engineers in the industry, sometimes if an equipment should fail, and if they find that an equipment is um, basically in storage, or it's even installed but it's not operating, sometimes they salvage parts, so sometimes and it basically boils down to documentation. Sometimes when the parts are salvaged, they might not document that they have basically removed their component and used it on another component. So basically, checking and verifying the readiness of these spare breakers is very important. Next is identifying a timeline for your replacement. That's very, very important, right? Okay, so in getting a good, grasp of a good timeline that you need to implement, right? It's much dependent on many factors. And what are these factors, right? The first one is the quantity of oil circuit breakers that you want to replace, right? Okay, so if there are many, then basically you should be looking to a much longer time strategy, right? Okay, then your risk score, right? Okay, so that itself, will tell you, the higher the risk score, then basically that tells you that that breaker is basically about to fail, or on the path to fail. So basically, you want to consider that. Then the asset condition, asset health index, right? So that itself also will tell you, the condition of the circuit breaker, and so that itself will tell you also, or basically tell you the timeline that you need to include that circuit breaker. Then your available capital, what is available, the funds, and what is budgeted. So that itself also helps to basically determine and implement a timeline for your strategy. Then your available resources, sometimes you might not have enough maintenance staff to help you with your and also you might not have enough engineering staff to help you. So that itself, and sometimes you have to outsource it. Give it to a third party vendor, to help you with that. So and that itself, attracts a lot of money with that. That is extra cost. So that also has to be considered. And a typical timeline that the industry utilizes is 5 years. So 5 years. I would say that somebody will select 5 years as against 10 years or 15 years based on, let's say, they have a high availability of resources and they have a high availability of capital, right? and also the risk score is very high, and the condition of the circuit breakers are not good, and the quantity of oil circuit breakers, I'll say it's not many, So that is when somebody will choose 5 years. Another person will choose 10 years, to basically leverage, spread out the costs, the available capital that should be available to replace these breakers. So that itself will also be based on, let's say, a moderate risk score and also a moderate condition index. And somebody will also choose to go with a 15-year timeline. And like I indicated, that itself, because what it's doing is basically you're spreading your capital, right? And if you don't have that amount of money, to basically, aggressively, replace them within 5 years, that is when you spread it out. And all that is based on you having a higher quantity of oil circuit breakers, right? And your risk score is not that high, and also your asset condition is not that high. Next is you're getting information for your risk score in your risk cost, right? I made mention that should be part of your Excel sheet that you're building, right? Okay, so that itself is obtained by your asset management department, and they do it through life cycle modeling of this oil circuit breakers. And matter of fact, they do it for different types of breakers and different types of substation assets. They do it for power transformers. They do it for battery system. They do it for switch gears and different types of equipment. Right? Okay, so the first thing that they consider, is the probability of failure. First of all, the risk cost is equal to probability of failure times consequence and cost of failure. Right? Okay, so that's how they determine the risk cost. So to determine the probability of failure, right? They consider the age, right? And how old is that equipment? Because I mean, as the equipment ages, the longer the age, basically the more deterioration it comes into play. Right? They also consider the manufacturer, right? Okay, so um, you know, some of these failures, are sometimes tied to the type of manufacturer, because I've seen, especially, I can give you a typical example, like an ITE breaker, right? I think that those that were manufactured before 1967. Those breakers, medium voltage breakers, were failing just like that, And so that is a typical example where basically the manufacturer probability of failure comes into play. So in that case, the probability of failure is going to be high for that manufacturer. Right? Okay. Then next is your asset health index, right? So that is your condition uh, index or condition score, and basically that one is evaluated based on different parameters that is tied to the oil circuit breakers, right? Oil testing and maintenance inspection and electrical testing. So all those parameters are assigned, scores and weights, and basically that's how they determine the asset health index or condition score. Then next is operational history, right? Okay, so depending on the cyclometer, there's something called cyclometer. So what is the cyclometer? It's based on the number of open, close operations of this breaker, right? So that itself will tell you the operational history, and also if the breaker has seen some failures, right? Okay, so that itself you see all that failure history in the asset management software. Then also industry-wide, they also go beyond and push out all the above and beyond the envelope, basically go into the industry and see, based on benchmarking and best practices, and see what industry-wide, failure with different types of circuit breakers, and based on the different models and different mechanisms that these oil circuit breakers have, and the number of faults that the circuit breaker has seen, so that itself is also factored into it. Next is the consequence and cost of failure, right? Okay, so the consequence and cost of failure is based on criticality, how critical, it's basically, that's oil circuit breaker. Is it feeding, basically providing power to critical customers? Next is the environmental cost, right? Okay, remember, I made mention that oil circuit breaker, basically it's a vessel, right? A large vessel that contains oil. Basically the oil is providing the electric medium, right? And also heat removal, right? Okay. So basically, if the oil circuit breaker should experience catastrophic failure, right? What is going to happen? Basically, there's going to be an oil explosion and oil spill, right? That oil spill has to be cleaned, right? And basically, this is a reportable event to environmental, health and safety. So that itself is additional cost. Yeah. Then also, I just said equipment. If you have an equipment that is in close proximity to the oil circuit breaker, right? Let's say a power transformer that is operating, reliably, in much close proximity to this oil circuit breaker, and if this oil circuit breaker should fail and explode, then the transformer can also be damaged, and that is also introduce additional cost. Next, much to talk about, the hazard, the personal hazard, right? Okay, so if let's say you have, like I said, if you have a vessel out there that has a lot of gas in it, and that gassing has not been taken care of, and so it builds up pressure, right? So if you have a personnel that is working in close proximity, that can create that can be a hazard, right? That explosion can be a hazard to any personnel that is, and a matter of fact, it can be a safety hazard to a personnel that is working in close proximity to this oil circuit breaker. Next is if there's a failure, right, and you have to utilize a mobile substation, right, and basically to continue to provide supply to your critical customers. Then basically, that cost of mobilization of that mobile substation also comes into play, right? Okay, and lastly, you are losing power to customers, right? And that is loss of revenue. Now, let's talk about the criteria that you need to consider in your selection strategy for these oil circuit breakers that needs to be selected and for replacement. Okay, so the list itself that you come up with initially, it's like it's going to change periodically with time, because a lot of factors are going to come into play on a daily basis, sometimes on a weekly basis. That will basically warrant basically the reshuffling of the list. So first one is the risk score, right? Okay, so the risk score can change. Let's say the asset management department provides let's say every 6 months they provide an update based on inspection results or testing results. They provide updates of the risk score to you. So that itself will adjust the position, will adjust basically based on the cost and the time left for replacement. So the time left for replacement also is a factor, right? Next is operational history, right? And problematic breakers. So as this field personnel go out in the field, right, and basically perform inspection, provide support to field calls, they come up, basically they encounter, breakers that are problematic, especially, I'll give you an example about one that had a problem with latching, the latching mechanism was giving us problems. We ended up, replacing the latching mechanism. Then basically other problems started coming up, those were hidden. So this basically becomes a problematic breaker that basically warrants immediate replacement. So the field operations and maintenance crew will provide an input to maintenance engineering for them to basically reprioritize, prioritize this particular breaker. So this breaker basically becomes, comes to the top of the list, basically to be scheduled for replacement. Then the failure rates with a certain type of breakers and manufacturer, and like I made mention that certain manufacturers, especially the ITE type of breakers, the failure rate, the medium voltage level breaker, the failure rate was so much that basically those breakers, need to be considered as part of the first year um, of replacement. Then you also want to leverage, as some of these substations, right, have been built, many decades ago, ranging from 40, 50, 60, 70 years, And a lot of them are basically going through full substation upgrade, replacement, and so these oil circuit breakers that are at a particular substation are going to be replaced, and they are going to be basically based on capital replacement, right? So what you do is, you leverage, with the project manager for that substation upgrade, and basically circuit breakers that are on your list as a maintenance engineer, you basically scratch it off because they are going to be considered for a capital project for a whole substation upgrade, right? Okay. So you scratch it off and create a different list, because the reason being that sometimes, even substation upgrade, future ones can be cancelled, due to unavailability. So basically, there has to be that collaboration between you and these project managers from project management, constant communication to find out whether the substation upgrade is in line, or it has been postponed, or it has been cancelled. Then, as you know, some of the substations, right, have many oil circuit breakers. Some of them have a mix of oil circuit breakers and SF6 breakers, and some of them oil circuit breakers, SF6 breakers, vacuum circuit breakers, right? Okay, so for substations that have many oil circuit breakers that are on your list, right, that you have in line to replace, you have it scheduled, is on your list to replace a particular oil circuit breaker, right? Since these circuit breakers are at a particular substation, they all have a different asset condition score, right? And also different risk score and risk cost, right? So let's say you're going to replace one breaker for the first year, right? And let's say the next breaker, within schedule for the third year, and the next breaker, let's say for the fifth year, and the next breaker for the eighth year, right? So what you do is you can basically leverage on basically manpower, and basically replace all those circuit breakers at a time, and that is also much dependent on the amount of funds, availability of capital you have at that time. So replacing all those oil circuit breakers at one substation at a time can also be done, and basically that can save time and also improve the reliability and power security network. Next is the material requisition piece, right? Okay, so like I indicated, every utility has an engineering department that's basically owns the specification for this circuit breakers, and basically they have put in place a blanket purchase order, that they constantly have with this major OEMs. Or OEM means original equipment manufacturer. So most of them is with General Electric, Siemens, and ABB, right? Okay, so and that is what they have in place, and these blanket purchase order are updated periodically based on the OEMs providing basically updates in cost of these breakers. Next, you need to come up with a portfolio of breakers that you're gonna use, right? You need to come up with that list, and as you know, for medium voltage application up to 10 kV, definitely you want to go with vacuum breakers, because it's much cheaper and much less costly, and to utilize vacuum breakers at the medium voltage level. And for 57 kV, 72 kV, 115 kV, 230 kV, and of course 345 kV, definitely you want to utilize SF6 breakers, because it's much also cheaper to utilize SF6 breakers at that voltage level. Then, as you know, most nations, matter of fact, in the United States, certain states are basically pushing for a non-SF6 alternative gas circuit breakers, and California, for instance, is basically as a means of net carbon reduction, carbon zero. They are pushing that by the year 2030, um, no utility should have an SF6 breaker in place. Yeah. So, um, and some of the states have also started. So basically, you also want to consider as part of your portfolio. Let's say you can consider, gradually, let's say 10 to 15% of your population, or 20% as part of your portfolio to be non-SF6. And thanks to technology, now it has been, there are, I think, in commercial operations, there's a 72 kV and 115 kV circuit breaker of utilizing non-SF6 gas or alternative gas dielectric medium. Now let's talk about the resources that you need to fully implement your strategy. Very important. With regards to engineering, right? Okay, so you should have a repository of engineering drawings, right? Okay, so what you want to do is basically, obtain those existing drawings for the oil circuit breakers. So that includes one line, straight line schematics, and wiring, right? Because that is what your drafter is going to use for your markup. And also, you want to field visit to gather more data. Remember, I told you that never trust what are on the drawings, because what are on the drawings. Sometimes drafters can make mistakes. So you want to field verify whatever information that you have for that oil circuit breakers. Technical data sheets and all those things. You want to verify what is in the field and what is on the nameplate on the breaker. Then you also want to, obtain drawings for the new breaker, right? From the manufacturer. Let's say if you have a Siemens breaker, new breaker, SF6 breaker that you want to use to replace, you want to obtain all the drawings, and those come with the breaker when they are shipped. Basically the schematics and wiring, and also the instruction manuals and operating manuals are also all shipped. Next is your drawing markup. So basically, the engineer basically does the drawing markup and gives it out to a drafter, basically to do the drafting. Then it's the drawing package. There's something they call the drawing package. After basically putting your drawing package, your drawing package basically consists of all, one line, straight line, schematics, wiring, elevation drawings, structural drawings, above grade, below grade drawings. Yeah. Basically, you create a maintenance request, and a maintenance request, you do it if you have an asset management software. You can create a maintenance request based on that, and basically that itself is an intelligent means of basically getting everything, the workflow process at one place. Then you can create a job plan for it and get a material list. Then put in your material requisition and basically create a purchase order for the purchase of whatever additional equipment, that parts that you need for the replacement of these breakers. Next is maintenance. Okay, so basically, you also want to collaborate with the environmental engineering, because like I indicated, this oil circuit breaker is a big vessel, right? That has the oil, so when you are going to remove it, there's the possibility that there could be an oil spill, right? Okay, so you need to check with environmental and basically coordinate with them and utilize maintenance engineering to remove the existing breakers. And basically, you need an outage, right? Okay, you need an outage. So that also has to be coordinated with operations to provide you the isolation and shutdown. And basically maintenance remove all the connections, from all the connectors and the cabling. Then the installation of the new breakers, right? Okay, so that itself also requires coordination, and maintenance does that. Then functional check, they do, as part of prior to pre-commissioning. Then they do the pre-commissioning and commissioning and startup, right? Then operations, like I indicated, they're the ones that will provide the isolation and shutdown for you, right? And basically, and also help you with your work down, So operations and maintenance are the ones that you need to perform your work down, to obtain, all the information, full information that you need to, do all your engineering design and drawing updates, and putting your drawing package together. Next, it's material requisition, and basically, your procurement department, it's the one that will provide the support for you to procure the parts and items that you need. You have provided in your material list in your maintenance request. With that, that comes to the end of my presentation. So if you like it, select the like button in YouTube, and also select subscribe in YouTube. Thank you.